imagine cosmic portals where objects could disappear, be ejected, or escape to some other place in space or time. Blast off to the warp side of the universe as scientists search for black holes, white holes, and wormholes. Are they frivolous fantasies or a science fact? The universe is a cosmic cornucopia, endless possibilities. Imagine a shuttle service to anywhere in the cosmos. It's not aboard a futuristic spaceship. It's a galactic ride through a wormhole, theoretical tunnel providing shortcuts through space and time. In theory, a wormhole has a throat connected to an entrance and exit called mouths, located in different parts of space. Albert Einstein's general relativity laws allow for the existence of wormholes. In 1930, Einstein and his colleague Nathan Rosen calculated the mathematics of one of these intergalactic pipelines. It became known as the Einstein-Rosen bridge. The Einstein-Rosen mathematical wormhole arose from studying black holes. A black hole is a region in space of extremely strong gravity. The gravity is so strong that there is no way for objects that get too near to break away from its gravitational pull. Nothing can escape a close encounter with a black hole, not even light. But Einstein never intended his wormhole as a tool for space travel. His wormhole is theoretically created at some moment of time. It opens up briefly, then pinches off. Anything that tries to pass through it will get crushed when it squeezes apart. After Einstein's wormhole was determined unstable in the 1960s, little research was done on the concept. Then, the sci-fi film Contact was released in the late 1990s. Based on the book by renowned astronomer Carl Sagan, it proposed that a wormhole could be used for space travel. Scientists began to investigate whether there might be a type of wormhole different from Einstein's that is traversable. But traversable wormholes needed something to prevent them from pinching off. The idea of a traversable wormhole captivated science fiction enthusiasts. It also reinvigorated the serious study of wormholes within the science community. The other end of a wormhole could be connected to a very dangerous part, with all sorts of exotic phenomena. It might even be the core of a star. Physicists do not know of any way that a wormhole might arise naturally in our universe. But can they be made artificially? Scientists proposed that perhaps traversable wormholes could be sculpted out of quantum foam, a subatomic bubble-like structure that might exist everywhere in the universe, on length scales a billion trillion times smaller than the nucleus of an atom. If one could be engineered or located in space, scientists contemplated other possibilities for a wormhole. Could it transport galactic vacationers to different points in time, as well as different places in space? Time machines have mystified movie audiences for 15 years. Could a wormhole be used for such travel? But wormholes as time machines pose unsettling questions. In the distant future, will Earthlings be able to travel to the past and perhaps change history? Scientific ideas considered far-fetched today could one day become as acceptable as the fact that the Earth is round. The laws of physics may allow for the existence of wormholes, tunnels providing shortcuts through space as well as time. So, could these cosmic subway systems theoretically be engineered into time machines? Einstein's general relativity laws reveal that time travel into the future is possible. They show that time is perceived differently depending on where one is in the universe and how one moves. Objects moving at close to the speed of light age slower than static objects. And objects near a gravitating body age more slowly than objects farther away. Forward time travel has been tested using highly precise atomic clocks. Scientists have placed one clock on the ground and another in a rocket flying high above the Earth. The two were compared using radio signals between rocket and ground. The clock on the rocket ticked faster. Physicists have studied whether wormholes could provide travel not only to the future, but also to the past. If there was a wormhole with one mouth near Earth and the other in the center of our galaxy, the rate of flow of time will be different at the one mouth than at the other when compared to the external universe. But when looking directly through the wormhole, the rate of flow of time appears to be the same. This difference in their relative ticking rates, as viewed externally versus viewed through the wormhole, would convert the wormhole into a time machine. What that means is that by entering a wormhole, we could leave here today and come out the other end of the wormhole hundreds or thousands of years earlier. But backward time travel raises disturbing paradoxes. Could one actually voyage to the past, change history? If the laws of physics permit wormholes, then how can those laws deal with the danger of changing history?